Today what we are going to see is the questions, okay, in-text questions. So let us do the in-text questions and how to work out on it. Okay, so here you have been provided with three test tubes. You have been provided with three test tubes. Okay, and one of them contains distilled water and one of them contains distilled water, and the other two contains an acidic solution and a basic solution respectively. Now, if you are given only red litmus paper, and how will you identify the contents of each of the test tube? So here we can identify the content in each of the test tube by using red litmus paper. Okay, by using a red litmus paper, by using a red litmus paper. So how to do it? Let us see how to do it. Okay, it's very easy, and this can be done by noticing the color change of the red litmus paper, and this can be done by noticing the color change. Okay, color change of red litmus paper. Okay, color change of the red litmus paper. So color change in the red litmus paper. This can be noticed by color change in the red litmus paper. Okay, red litmus paper. Okay, red litmus paper. And how can it be done? So let me say that if the red litmus paper changes to blue color, the solution is basic. If the red litmus paper, okay, if the red litmus paper, okay, if the red litmus paper changes, okay, red litmus paper changes to blue color, okay, changes to blue color, changes to blue color, blue color is a basic solution. Then it is a basic solution. Then it is a basic solution, isn't it? And then it is a basic solution, I say it. If the red litmus paper changes, if does not change, there is no change, and if you experience there is no change, then it is a acidic solution. If the red litmus paper shows no change, shows no change, then it is a acidic solution. Then it is a acidic solution. Okay, and next part is if the red litmus paper changes to purple color of the solution in distilled water. If the in distilled water, what happens is if the red litmus paper, okay, litmus paper, red litmus paper changes to purple color, changes to purple color, okay, changes to purple color, okay, changes to purple color of the solution, okay, of the solution is called is distilled water. Okay, is a distilled water, is distilled water. So here what you're going to learn is nothing but very simple and very simple. Okay, if the red litmus shows no change, and then it is acidic solution. If the red litmus paper shows a changes to blue color, then it is a basic solution. If the red litmus paper changes to purple color of the solution, and it is a distilled water. Okay, and now we go for the understanding the chemical properties of acids and bases, and let us see about more about it, understanding the chemical properties and acid and bases in the laboratory. And we have to collect the solution of the science laboratory: hydrochloric acid, sulfuric acid, H2SO4, and nitric acid, HNO3, and acetic acid, CH3COH. So all these acids you have to, acids and bases you have to collect it, and you have to put a drop of each above solution in a watch glass. One by one you have to test a drop of indicators shown in the table. So what is the indicators shown in the table? Let us see it. Now, what changes in the color do you observe with red litmus paper, blue litmus paper, and phenolphthalein solution methyl orange? And the tabular your observation. And already I explained in the first part, that is about red litmus, blue litmus solution, phenolphthalein solution, and methyl solution. So let's see about this experiment. So how it can be done, and let us see about this experiment. So here the activity asks us to test various acids and bases with various regions one by one and see the result. Various regions mentioned here are pH indicators. We can use them in chemistry practicals. Blue litmus paper is a region test for pH. Okay, blue litmus is a solution. Okay, the blue litmus is nothing but a pH range to test the basic in nature. Okay, to test the basicity, and it acidic pH turns at red. In red litmus paper, it will turn pH blue in basic pH. And phenolphthalein is a silent. It is a colorless reagent, and it is turns pink in basic pH. And methyl orange, it is a narrow range pH indicator. At pH below 3.1, it is red, and at pH above 4.4, it is yellow. So this is what about it. And here the stronger acids like hydrochloric acid, sulfuric acid, nitric acid, and they have very acidic pH. So it turns blue litmus to red and gives a red solution. And okay, so you have to write all the samples, whatever your it is. Okay, let us write the samples, and then we will indicate, we will draw the conclusion about it. Okay, then we draw the conclusions about it. So let us see the indicate what are the samples. So here the samples are, first one as a HCl, we have it. Okay, we do have a HCl, first one as a HCl. So write down here HCl. Okay, hydrochloric acid and H2SO4, and we have H2SO4, and then HNO3. Okay, HNO3. Okay, HNO3 is nitric acid. Okay, next CH3 acetic acid, CH3COOH is an acetic acid. NaOH. Okay, NaOH is a basic, OH is a basic, sodium hydroxide is a basic, KOH is also a basic, and Mg, okay, magnesium hydroxide is also an a basic. Then calcium hydroxide, CaOH twice, is also basic. So how do we write? So first of all, in red litmus paper, so these all are acid and these all are bases, correct na? These all are acid and these all are acids. Okay, and these all are bases. So how do we write it? See, here what we have got is, we have to do red litmus paper. Here all the acids, red litmus paper will remain unchanged. Okay, red litmus paper will remain unchanged. Okay, will remain unchanged. Okay, what about blue litmus paper? Here the for bases, it will definitely will change. It will turns to blue. Okay, red litmus paper. Okay, litmus paper. It will turn to blue. Turns to blue. And what about phenolphthalein? And what about blue litmus paper? Definitely blue litmus paper. Okay, blue litmus paper. It will turn to red. Definitely, it will turns to red. And here blue litmus paper will remain unchanged, remains unchanged. Okay, it will remain unchanged. So coming to the phenolphthalein solution. Okay, all the acids, okay, all the acids, okay, in all the acids, okay, under phenolphthalein solution, it will become colorless. Okay, colorless. And methyl orange, it will turn pinkish red color. It will turn pinkish red color. Pinkish red color. Okay, it will turn pinkish red color. What about bases? Okay, let me teach about the bases. And for all bases, here the phenolphthalein solution will turn red or pink. Okay, it will turn red or pink. And for methyl orange solution, it remains yellow. It remains yellow. Okay, it remains yellow. So this is what about it. And about this experiment, should I have to tell about it, this experiment. And this experiment is all about the activity and collecting all the similar stronger bases like sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide. Okay, calcium hydroxide, potassium hydroxide, acetic oxide, ammonium hydroxide turns red litmus to blue. Then with phenolphthalein solution, they give pink a solution. In phenolphthalein solution, they give a pink solution. And methyl orange, they give yellow solution. For weak acid and bases, pH of a weak acids and bases depends upon their concentration. For example, if you go to take an acetic acid, so what happens to the non-acetic acid? Let us see. So here the acetic acid, 1 million, 1 mole of solution has pH of 2.088, so it turns blue litmus to red one. Phenolphthalein indicates only basic pH, so there is no change in the color of the phenolphthalein. It turns methyl orange into red. And different pH indicators give different colors with the acids and bases. An acid turns the blue litmus paper red, while the base reverses this, and bases give red color with phenolphthalein, while the methyl orange, it gives yellow solution. Then the methyl orange gives you yellow solution. Similarly, the acids give red color with methyl orange, and acids give a red color with methyl orange. And what we did is your indicators in acid base reaction to finding an endpoint after completion of the reaction, any addition of the reactant changes of the pH solution. And I had to tell about this one, and I already told about blue litmus is a reagent. Okay, test for basic pH. Okay, this is the basic pH. Okay, basic pH, it will basic pH it will indicate, and basic acid it will indicate. Red litmus, basic blue in basic pH. Okay, and it will turn, actually blue litmus paper, it will turn red, and it will turn to red in color. Okay, and that means it is an acidic in nature, we say it, isn't it? Similarly, red litmus also, it will basic in pH. Okay, and now phenolphthalein is a colorless reagent. It is a colorless reagent. It is always a colorless reagent. It turns pink in pH. And methyl orange is a narrow range pH indicator. It is pH is below, it is below 3.1. Okay, it is red, and the pH above it is yellow. Okay, it is red when it is pH is 3, below 3.1. It is above 3.1, it is a yellow in color. Okay, yellow in color.